Okay. Our lesson today is surface area. Surface area is the amount of two-dimensional space of all the faces, or we can call them sides, of a three-dimensional figure. In order to find the surface area of a figure, you find the area of each side. I'm going to rewrite that. I don't like that. Surface area is the sum of the areas of each side. So if you have, for example, if you have a rectangular prism that measures 20 millimeters tall, 8 millimeters wide, and 15 millimeters deep, you would need to find the surface area of each side and then add them together. It helps to draw a net, which is, if you thought of this as a box and you cut along each edge, you would be writing the individual panels of the box. So I know that this is three-dimensional. So I can count my sides. I have a front and a back, a top and a bottom, and a left and a right. So I'm going to start with my bottom here, this piece right here. So this piece is a rectangle that's 8 by 15. And then the side here is attached to the 15. So it comes out this way. And it's 15 along the bottom. And then how high is that side? Well, that's this measurement. So this is 20. The opposite side is identical to that, the left and the right, 15 by 20. And then the front is attached to the 8 here, and it's also 8 by 20. And the back matches the front, 8 by 20. And then we're left with the top. And the top is identical to the bottom. So I'm just going to attach the top here, and I know the bottom is 8 by 15, so the top is also 8 by 15. Now I find the area of all 1, 2, 3, 4, 5, 6 sides, and I add them together. So I have the area of the top and the bottom, which are going to be the same. And it's a rectangle, so the top and the bottom are these two. Here's the bottom, 8 by 15, because it's a rectangle, so length times width. And the top is identical, 8 by 15. And 8 times 15 is 120. Then I want the area of the left panel and the area of the right panel, which are identical. The left and the right, they're both 20 by 15. And 20 times 15 is 300. And then I want the area of the front and the area of the back. And the front, they're the only ones I haven't used yet. I've used this one and this one, and this one. I now have left the 20 by the 8. And 20 times 8 is 160. Then I know that I want the sum of the area of each side. So I add these. and I get 1,160 square millimeters. Rectangular, square, or other quadrilateral figures will have 6 faces. If you don't get 6 numbers and add them together, if you're looking at a rectangular prism, a square prism, or some other kind of quadrilateral prism, and I'm going to write prism here. All 3 of these I'm talking about prisms. You're not doing it right. You need at least 6 numbers because you're always going to have a front, a back, which are going to be equal, the left and the right, and the top and the bottom. The only other kind of prism that you're going to deal with is your triangular prism. And a triangular prism looks something like this. It still has a front and a back, which are equal. But instead of having a left and a right and a top and a bottom, a triangle only has 3 sides. So you have 3 faces. And we call them lateral faces because they're on the sides. If your prism were drawn this way, then the front and the back would actually be the top and the bottom. But you would still only have 3 lateral faces. This one, and then that back panel. So I guess you could technically think of it as a left and a right and a bottom, or a left and a right and a back, but there's no 4th piece. You would still solve it the same way. If you had a prism that was, let's say, 7 feet, 8 feet, I know this is not to scale, and then the height from top to bottom, so remember your height of your triangle is from the top perpendicular to the base, let's call that 3 feet. You would still draw your net, there's my bottom piece, which is 7 by 8, and you would draw the 2 side panels here, which are 7 by, oh, they have to give us this. This is 5 feet here. So these are 7 by 5. The diagonal part here is 5. And then the front and the back triangles are attached to the 8. So these are 8, and the height here is your 3. So I find the area of the front and the area of the back, which is just half my base, which is 8, times my height, which is 3. 8 times 3 is 24. Half of 24 is 12. The back and the front are identical. Then I do my rectangles. I have 2 that are 7 by 5, so the area, I'm going to call this the right and the left, is a rectangle 5 by 7, which is 35, and 5 by 7, which is 35, and then I just have my bottom panel here, which is 8 by 7. So the area of the bottom is 8 by 7, which is 56. I'm still doing surface area, so I'm going to add it all together. And my surface area is 150 square feet. The key is drawing the net. So as long as you draw the net and your triangular prisms have 1, 2, 3, 4, 5 faces. So if you're doing a triangular prism and you don't get 5 numbers, you're doing it wrong. If you have your rectangular pieces and you don't get 6 faces, you're doing it wrong. The only one that's left is a pyramid. And a pyramid has some shape of the base. It could be a rectangle, it could be a triangle. And then it has 4 triangles for its sides. So the net here is really easy to draw. But it can be a little more difficult to figure out the measurements. So you want to pay special attention to what you're doing. So let's say this is a 10 by 10 square, and the height of the triangles is 7. So then each of these would be 10 by 10, but the height of each triangle would be 7. So the area of all the triangles would be the same. Half the base, which is 10, times the height, which is 17. Well, 10 times 7 is 70. Half of 70 is 35. And how many do I have? 1, 2, 3, 4. So times 4 triangles gives me 140. Then all that's left is my base, which here it's a square, so 10 times 10 is 100. I add my 2 areas and get my surface area of the entire pyramid. This would work even if you were doing the area of, let's say, a triangular prism. You would just do the area of the base and it would be a triangle. So now you have enough information to find the surface area of whole pieces. You also, there is a formula for surface area of prisms. And that's the perimeter of the base times the height plus 2 times the area of the base. So you could do the perimeter of the base times the height and add that to 2 times the base area. For a rectangular prism, you could do that. I like the nets better, but it's up to you what you want to use. The only thing you have to be careful of is if you have a composite figure. Let's say you have a house or a shed of some sort, and they want to paint, let's say they want to paint the whole outside. Well, here's where you just have to be careful because you're not going to use every surface. If I'm just going to paint the outside of a house, that means I only want to paint the 4 walls, so I'm only going to have the front, the back, the left, and the right. And if I'm painting the roof, I'm only going to have the front, the back, and the left and the right. Okay, so I'm not counting the top or the bottom of the prism, of the square or rectangular prism, and I'm not counting the bottom of the triangular prism because I wouldn't paint that. So you just have to be careful what they're asking for. This is the only thing that would change how many faces you had if they weren't going to have you count one of the faces. But then you would just do the same thing. You'd find the area of all of these, base times height, half base times height, base times height, and then you would add them together to get the composite, because composite means total and total means add. Now you can go through and do your alternative lessons and your practice, and then once you feel comfortable, you can come and get the review quiz.